Hi everyone, we're going to work through some problems on trig from Abramson sections 7.3 and 7.4. In particular, we're going to work through some problems that will show up on your Friday assessment, these kinds of problems. We're just evaluating trig ratios at special angles or angles within families of our special angles. I'm going to show you the way I do it. There are lots of different techniques and tips and tricks, and so if you have something else that you prefer or a friend shows you a way that you like a lot, feel free to do it in a different way. But maybe learn something from how I do it. So we're going to start out with this first problem, which is cosine of pi over 6. And this one basically you should have memorized. And so personally, I use the special triangles, which we can see over here on the side of the screen. But you can use something, the chart method, where you draw out the little chart of these values, or the hand method, where you put your finger down and count at the different sides, or some people prefer to memorize the values written into the unit circle. So you can use any of these methods, is fine. Some people I know feel a lot more comfortable memorizing all the values for the entire unit circle, which you're welcome to do. I would challenge you after you get comfortable with that to try to move away and at least only memorize the first quadrant and then use that first quadrant to figure out angles in other quadrants. This can means that you don't have to memorize quite as much, so it helps a lot with that. And avoiding mistakes in the memorization. Okay, so I'm going to show you cosine of pi over 6. The way I do it, you could just straight up have it memorized. I don't. I go back to the special triangles. And so in particular, we're looking at this first special triangle over here, and we want the angle pi over 6, which is up in this corner, and cosine of pi over 6. So it's always going to be the adjacent side, which is square root of 3 over 2, divided by the hypotenuse, which is 1. Okay, so this is square root of 3 over 2 divided by 1. Anything divided by 1 is itself, so this is just square root of 3 over 2, and we're done. And again, you might even just straight up have that one memorized. Okay, number 2, I'm going to do tangent of 3 pi over 4. Okay, so there are basically two things we need to know. One is, what's the reference angle? Okay, and for these special angles, the ones that we do, it's almost always the angle that has the same denominator. You have to be a little bit careful. If it was something like 8 pi over 4, you have to divide out first. It's 2 pi. But most of the time, it's just the same as the denominator. So in particular, the reference angle here is going to be just pi over 4. Okay, and then the other piece of information that we need to know is what quadrant is this angle in. Okay, so which quadrant? And that can be a little bit tricky to figure out when you're just getting started. So 3 pi over 4, there are lots of different ways to think about it. And if you're having trouble with it, what I would say is you're looking at a few different cases. Either we're going to be in the pi over 3 family, or the pi over 6 family, which you're going to treat separately, or the pi over 4 family, or it's possible that it's an angle that lands on one of these axes. So in this case, we're in the pi over 4 family. And so what you can do here, if you're having trouble, is you can draw out your axes, and you're going to take pi, which is half of a circle, and divide it into 4 pieces so that you know what a pi over 4 looks like. So you take pi and you divide it into 4 pieces. Right, so you have these 4 different wedges, 1, 2, 3, 4. Right, so you start over here at 0, and you end up over here at pi. And then you draw the same thing on the bottom side. So again, you divide it into 4 pieces. And then you want 3 of them. So color here, right? So you always start over here at the positive x-axis, and we go 1, 2, 3. And this is where 3 pi over 4 lands. This angle here is 3 pi over 4 in red. And so the point that we want is over here. And so in particular, we're in quadrant 2. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, and so now to figure out tangent of 3 pi over 4, the first thing we do is we figure out what's tangent of the reference angle. So tangent of pi over 4, which is not quite what we want, 3 pi over 4, we want tangent of pi over 4. And now we can go back to our special triangle, or you can go to your chart method or your hand method or the unit circle, whatever you have memorized. And tangent of pi over 4 is the opposite divided by the adjacent, right? So katoa. And here the opposite is 1 over square root of 2, which is the same as square root of 2 over 2. and you divide by 1 over square root of 2, and you divide by itself and you get 1. So write it out though. 1 over square root of 2 divided by 1 over square root of 2. You can either think of multiplying by the reciprocal, or just know that anytime you divide by itself, you get 1. Maybe I shouldn't circle it because that's not our answer. That's just on our way to the answer. So tangent of pi over 4 is 1, but we want tangent of 3 pi over 4. And so the way these things work, as we've learned, is that tangent of an angle that's in the special family is going to have the same value, but it might be negative instead of positive. So we have to check, and that's why we need the quadrant. So the quadrant is quadrant 2, and we know that tangent is sine divided by cosine, and so it's going to be the y value divided by the x value. So when I say 1 over square root of 2 and 1 over square root of 2, we actually should be a little bit more careful. So I'm going to mark this up a little bit. So the 1 over square root of 2 is the y value, right, is sine over cosine. So the one on top is the y value, right? And so the y value here is above the x-axis, so it's positive, so that's fine. But the dividing by cosine, for tangent of pi over 4, when you divide by cosine, the 1 over square root of 2, when we do it for tangent of 3 pi over 4, the x value is negative. So a positive divided by a negative is going to give us a negative. So tangent is always going to be negative when we're in the quadrant 2. And so tangent of 3 pi over 4, which is the one we're interested in, is actually, if you want, 1 over square root of 2 divided by minus 1 over square root of 2, which is minus 1. Or you can just say it's the negative of tangent of pi over 4 because we know it's in quadrant 2. Okay, if you like, you can use the little mnemonic device. All students take calculus, and that tells you that all of the trig ratios are positive in the first quadrant, over here. Sine is positive in quadrant 2, but tangent and cosine are negative. Tangent is positive in quadrant 3, but sine and cosine are negative. Cosine is positive in quadrant 4, but sine and tangent are negative, right? But we also know these from the x and y values, which is a nice way to do it. Okay, so that's tangent of 3 pi over 4 was minus 1. Let's do another one. So our next problem is going to be sine of minus 4 pi over 3. Minus 4 pi over 3. Okay, and so we're going to do this same thing. So we want to know the reference angle here. So the reference angle, again, 4 and 3, right, we can't divide that to reduce it any further. So our reference angle is going to be pi over 3. And we want to know which quadrant this is in. So this is probably the trickiest part of this problem. And so we're going to do a similar method. So we're going to set up our x and y axes. And I really recommend you do this separately for the different families. So this is pi over 3. So we take pi, which is halfway around the circle, and divide it into 3 pieces this time. So the tricky thing with the pi over 3 family is that you don't count the y-axis when you're doing this. Oops, oh, I just sometimes it turns on my eraser. Okay, so go back to purple. So we've done this pi and pi over 3. So you get 3 pieces, 1, 2, 3. They should be even, except my drawing's not very good. We get the same thing on the other side. So we take this pi and we divide it into 3 pieces. And then we want to count out 4 of them, but we want a negative angle. And so when you're doing a negative angle, you need to go, always start over here at the positive x-axis, right? But now you want to go clockwise. So normally for positive angles, we go counterclockwise. Now we're going clockwise, that's the negative part. And then the 4 says we want to count out 4 of these wedges. So we do 1, 2 brings us all the way over to here. We skip over the y-axis. 3 brings us to pi, which it should, because 3 pi over 3 is a full pi. And then the 4th pi over 3 brings us back to quadrant 2. So just like the last problem, we ended up in quadrant 2 just by coincidence. So this is quadrant 2. Okay, and then we know that our reference angle is pi over 3, so we want sine of pi over 3. Okay, again, hand method, chart method, unit circle, whatever you want. I like to use the special angles. So sine of pi over 3 is the opposite, which is square root of 3 over 2. Divide by 1 stays the same, so it's just square root of 3 over 2. or you might have it memorized, especially if you're practicing enough, you probably have it memorized. So this is square root of 3 over 2. But we don't want sine of pi over 3, we want sine of minus 4 pi over 3. Sine of minus 4 pi over 3, which is the exact same value, except it might be negative, so we have to check. But over here in quadrant 2, remember sine is the y value, right? And the y value is going to be positive because we're still above the x-axis. So this is still going to be positive square root of 3 over 2. Okay. So Keith is trying to tell me to use the do not disturb setting because I was complaining about everyone interrupting my attempts to make videos, and my do not disturb setting apparently doesn't apply to Slack. Okay, so sine of pi is the next one I want to do. Sine of pi. Okay, so the ones we've done so far were in the pi over 3 family, the pi over 6 family, and the pi over 4 family. Pi is one of these angles that in some sense it's so easy that it becomes hard because we forget about how to handle these. So this is one of our angles that actually lands right on the axes. And so we don't need to do anything fancy, we just use the fact that you're on the unit circle, right? And so your values are all going to be 0 or positive 1 or negative 1. Or if you're dividing, it could be undefined. So sine of pi, we can just draw where pi is on our unit circle. So pi, you go exactly, you always start on the positive x-axis, and you go, oops. Just a second. Someday I will learn how to use this thing. Okay. So we go, start over here on the positive x-axis, and we go exactly pi, right? So the angle is a rotation by pi, or 180 degrees. And sine of pi, so that means we land over here at this point on the unit circle, which is the x value is -1, and the y value is 0, because you're right on the x-axis. And sine is the y value, so this is just equal to 0. That's all you have to do. Okay. Similar, but a little bit tricky too, is sine of something like 5 pi. Okay. And so here you've got an angle that's bigger than 2 pi. So you're going to end up going around the circle more than once, okay? So let's do a different color. Oops. Our axes again. So sine of 5 pi. So I'm going to redraw my axes down here. And I'm going to pick a different color. And 5 pi. So we know if we go all the way around the circle once, that's 2 pi. So if we go all the way around the circle the second time, that's 4 pi. And then we keep going one more time is 5 pi. So we land exactly back here when you're on the unit circle, still in the same point. Sine of 5 pi is also 0. Okay. Let's do another one. Let's do one more. So number 6, this is sine of 3 pi over 2. And this one also lands on the axes. So 0 and pi, or any multiple of pi, they're all going to land on either your x-axis, one side or the other. The pi over 2, 3 pi over 2, these guys land on your y-axis. So again, we'll just draw here. Okay, and if you want, you can again think about it sort of like we did with the pi over 3 and pi over 4 and pi over 6 families. So pi over 2 is you take pi and you divide it in half. So pi over 2 lands up here. Is that far? Maybe I shouldn't write it in because of confusing later. And then pi goes here, and then 3 pi over 2 gets you over to here, right? And 4 pi over 2 would get you back to the full circle. This point here, we can just see on the unit circle has x value is -1. You're 1 unit below the x-axis. And, oh, sorry, I did it wrong. It's so easy to get these the wrong way around, right? The x value is 0. You haven't moved off of the y-axis, and the y value is -1, okay? And sine is the y value, so this is -1 in this case. Okay. And so that's how I approach these different kinds of problems. Of course, if you have tangent, you do sine divided by cosine. If you have cosecant, it's 1 over sine, et cetera, et cetera. And really, it takes practice, right? And I really just like to think of it as those different categories of problems, either the ones that land on the axes in the pi and pi over 2 family, and the just general regular special angles that we know, and the ones that are negative, you have to have your angle go the other direction. So you have a few different categories, but just practice a lot and you'll get better at it.